Hi everyone, it's so nice to see those who love physics and math. Today let's talk about jumps on the moon. And you could probably hear that a man on the moon weighs 6 times less. That's why probably he or she could jump up 6 times higher. And people start thinking that, okay, if a world record is about 2 meters and something, then I could jump maybe 12 meters on the moon. Is that true or not? First of all, if you're thinking about sportsmen, athletes who are doing special kinds of jumps, they're running before that specially. They kind of make everything set to make this jump, to make this overturn and all that stuff. But when you just normally jump on your feet vertically without pulling legs to your chest, okay, then the height between your feet and the floor would be just about 30, 35, probably 40 centimeters if you are trained. I just checked it by myself before doing this problem, okay? That's why let's set the following text. If man has 75 kilo mass, Armstrong had something around it, and jumps up to the height of 35 centimeters, is the height of feet above the floor on Earth, then what would be the height of his jump on the moon wearing spacesuit? Remember, we cannot just jump on the moon. We should wear a spacesuit. And spacesuit is a special device, which is quite heavy. Spacesuit mass, which astronauts used on the moon, was about 91 kilo. Okay, it's more than the mass of man itself. Okay, Earth gravity, we know, or gravity acceleration, is 9.8 meters per second squared, or Newton per kilo, and moon gravity is 1.62. Okay, with this data, let's just think what could be the height of the jump. Basically, what makes jump possible? Let me move it a bit to the left. What makes jump possible? Some energy which is produced by muscles. This energy would not be changed on the moon. Furthermore, there would be some obstacles to produce the whole amount of this energy because spacesuit is not organized to jump. It's not athletic suit, it's spacesuit. That's why it would be even less, but we would not consider it, okay? Now, if we produce some amount of energy and it's same on the Earth and on the moon, then how could we measure it? It's quite complicated topic if we talk about body mechanics. It's really complicated and tough. All the levers are kind of weirdly organized and not so easily calculated. But generally, let's say that if we jump up to, let me just draw it. If we jump just up to certain height, like this, let us consider that this height is the increase of potential energy, okay? Strictly speaking, we should not talk about that height, and it would even decrease our number. We should talk about the center of mass of body lift above the floor. And center of body would surely on this picture lift higher, but it would lift less. It would lift less even. That's why let's just consider the distance between the feet and the floor. This one is 0.35 meters. Yeah. This is our age of jump on Earth. Let's mark it as sub E, okay? Meters, of course. And basically the whole energy of muscles is transformed into the energy, into the potential energy of the body. But let's calculate it again by the HE, this 0.35. 0.35. Now, it means that the energy of jump would be mass of a person, okay, mass, a bit weird writing, like that is better, times Earth gravity, G sub E, okay, times H, height of jump on Earth. But if we think that we're jumping on the moon surface, the amount of energy produced by muscles is the same or less, again, because the suit is not constructed for jumping. Now we'll have mass of a person plus mass of a suit, okay, M sub S, times moon gravity now, G of the moon, and height of jump on the moon. That's it. If it's the same amount of energy, we could state that both formulas are equal to each other. That's why I could write that M plus M sub S, my mass and mass of suit, times G on the moon, times H on the moon, would be just equal to my mass times G on the Earth times H on the Earth. Okay? Now, let's just derive H from here. Nothing else special. We should derive H, and H would obviously be H on the moon. M, mass over person 75 kilo, times gravity on Earth, gravity acceleration, times height of jump on Earth, divided by sum of the masses of man and the suit, plus Shoya, ms, times gravity of the moon. Let's substitute the numbers. 75 kilo times 9.8 times 0.35 divided by, in parentheses, 75 plus 91 times 1.62. Moon gravity. If we carefully calculate all the numbers, we'll get 0.96 meters, which is 96 centimeters. But it's overestimation one more time because of several reasons. First of all, we should consider the center of mass being lifted up, and this would decrease the height. Then we should consider that the suit is not made to make jumps, and it will be much harder to do this jump on the moon. But even if you could, the jump would not be higher than 90 or so centimeters, which is basically quite reasonable. No 12 meters jumps, no 5 meters jumps, no anything like that. And if you see the chronicles, the videos which were made on the moon, the only difference with the jumps on Earth is that jumps are kind of made with a different time scale, let's say, yeah? They look like kind of slow lift and slow move down, slow landing. That's basically it. If you have any suggestions, what kind of problems to review or to solve or to consider or to explore, okay? If you have any topics to go into, please share. I would be happy to respond and record videos on that. At this point, I would like to finalize this video. Wish you all the best in your studies, in your tests and exams. See you and bye.